Welcome to my first proper video. Today I'm going to be going through atomic structure, time of flight and isotopes, so relative atomic mass, and calculating it, and hopefully at the end I've put together some exam questions from the new specification papers only, as that's the most beneficial for you. So time of flight is what I want to really look at in depth, as that is what's new in this new specification. It's quite new, and I know a lot of people have asked me to go through that as they are struggling to do so. So, just to start off with, simple GCSE knowledge, atomic structure, yeah? Just quickly cover atomic structure quickly, and then we can move on to the harder stuff. So, what does an atom actually consist of? We know it consists of a proton, a neutron, and electrons. And we know a nucleus is made up of the proton and neutron, so they are both found in a nucleus. And what do electrons do? They orbit. Yes, so they're found in the orbital, they're not part of the nucleus. Relative mass, we all know proton has 1, neutron is 1, and electron, well, electron varies, but they're very, very small compared to a proton and neutron. So you can either have 1 over 1840, or I know some books have 1 over 2000. They're all right, it doesn't matter, you won't get this wrong. To be honest, I don't think they'll give you an easy question like this in the exam, but if they do, you're right. It's just different books have different masses of the electron, but it's all the same. I think they just probably rounded up differently. Anyhow, it's just what you need to know is electrons are very small. The relative charge, we know proton as +1, neutron is neutral, and electron is -1. So if I just give you a quick example of lithium, we know lithium has a mass number of 7, and we know it has an atomic number of 3. What does atomic number consist of? This consists of the protons and electrons, and this one is the number of neutrons plus protons. So the 3 have the same amount of protons and electrons. So when you look at the atomic number, you know that's the number of protons, the same for number of electrons. Also, when you look at the 7 for the mass number, we know the mass number contains the neutrons and protons. So if you want to work out how many neutrons there are, you would do 7 minus 3 to give you 4, and that gives you the amount of neutrons there are. Simple GCSE revision. Right, let's move on to time of flight. So this is new to the specification, and there's 4 stages to this. So the first stage we know is ionization. Second stage is acceleration. Third stage is the flight tube. And the fourth stage is the detection. Now, what people get confused by is that ionization has 2 steps in it. It has 2 stages. So it has the electron impact, that's my abbreviation for electron, and the second one, which is the electrospray ionization. And they're both different, but they're not steps of the time of flight, they're part of the ionization, so you choose one. So if they give you an exam question, I'll show you an example later on, you choose one, you don't describe both unless it says so. So the steps are actually 4, ionization, one of the 2, acceleration, flight tube, and detection. So I'm going to go a bit into depth into each stage now. So let's actually do this on another slide. Draw this out for you. So this is my time of flight tube. This is my detection box. So it's got D for detection. I'll explain to you in a minute what each of these stages mean. Okay, so just labelled each stage so you know, so it makes sense to you. Now the first step, as we said, is ionization. Now ionization, I'm going to go through 2 processes, the electrospray first, and then I'll go through the electron impact. So the electrospray, what happens is a sample is dissolved in a volatile solution through a needle. So the tip of the needle has a high voltage, and that's what's important, and that's what you need to really remember, that the tip of the the tip of the needle has a high voltage because the sample is dissolved in a volatile solution, right? So that's electrospray. Now that vaporized sample is what's injected at low pressure. So that vaporized sample gets injected here at low pressure. Okay? It gets injected at low pressure, and because the tip of the needle has a high voltage, at that tip, that's when the particles gain a proton. So they can gain a proton, and then they go into the acceleration stage. So it's pretty simple. Sample dissolved in volatile solution through needle, tip has high voltage, that's where it gains proton. Now the electron impact, right? Oh, sorry. So the second one is electron impact. Electron impact is a bit different. This is where high energy electrons are fired at the sample by an electron gun. So the sample is bombarded by electrons from an electron gun. Therefore, this knocks electrons from each particle, and that forms a positive ion. So whereas the first one, it gains a proton to form an ion, this one loses an electron from each particle in the sample to form a positive ion, due to the gun that bombards the sample with electrons, therefore knocking it off. So just imagine lots of electrons coming towards you, one falls off, and that forms an ion. From the first one, they gain a proton from the solvent as they leave the needle, producing ion, and the second one, they're bombarded by electrons, knocking an electron off, forming an ion, a +1 ion. And this is where the equations would come in, the first ionization energy equations. Yes, simple ones like, let's say, for example, magnesium forms magnesium plus electron. Yes, and I'll go through more of that later on during the videos. So that's ionization. Now, the second step, now that they've decided which one, they go into acceleration. I've drawn this kind of weird looking shape, but it's supposed to be a plate, a negatively charged plate. That's quite important. You remember the key words negatively charged. Now the positive ions are attracted towards the negatively charged plate. So the positive ions are attracted, the ones that have just been bombarded or they've just formed through electrospray, they're now attracted towards this negatively charged plate. And that is acceleration. That's all about acceleration. They're attracted by this electric field or by this negatively charged plate, because opposite attract. Now number 4, the positive ions are accelerated by electric field, and they all have the same kinetic energy. That's quite important. All ions have same kinetic energy. This is really important that you remember this, okay? Also, kinetic energy, we all know the equation, yes, as half mass volume squared. Now, because all ions have the same kinetic energy, therefore, velocity, which means speed, velocity depends on abundance of mass. In other words, the velocity basically depends on mass. It doesn't depend on kinetic energy. So how fast the ions are moving through this time of flight depends on the abundance of mass. So depending on how fast ions are moving, it's all about their mass. So if they're charged +3, whereas the other one's charged +1, +1 will be faster moving. Like vehicles, when you have a big truck and you have a small car, a small sports car, the small sports car is more likely to have a higher acceleration, higher velocity due to its mass, due to its weight. Yeah? So simple, that's all. Then the flight tube, the negatively charged plate has holes in it. Now this negatively charged plate has holes in it, so the positive ions then go through it. They obviously go through the holes. And again, like I just discussed, that's when, depending on how big they are. So this one is probably going to be slower, whereas these little ones are probably going to reach the detector faster. And the last step is detection. This is when the ions have hit the detector plate, and therefore they become discharged and they gain electron. So ions hit plate and they become discharged. this means they gain electron. So whereas in the beginning they may have lost it, they're now gaining an electron as they hit the detector. And as they hit the detector, a current is passed. Okay, so as they hit the detector, the ions, they, due to electrospray, electro impact, they pass the negatively charged plate through the holes. Now, depending on their mass, they have different velocities, but same kinetic energies. They then hit the detector and they become discharged and gain an electron. As they hit the detector, a current is produced. That is quite important that you get that down. So current is produced when they hit the detector. Size of current, again, is proportional to the abundance of particles. So the size of the current, or how big the current will be that's produced, is proportional to the abundance of particles. Last but not least, I drew this vacuum pump. This whole thing is done under vacuum, again, to prevent it from colliding with particles from the air, just what a vacuum is basically used for in anything you do in chemistry. So that's pretty much it, all you need to know. Last thing that I want to look at today is relative atomic mass, RAM. So what is relative atomic mass? It is the isotopic mass times percentage abundance divided by 100. Also, this is really important to note that if they don't give you the percentage abundance in the exam, instead they give you relative abundance, what happens is you don't divide by 100, but you divide by the total relative abundance. Because you may have noticed from exam questions that you've done that it doesn't always add up to 100. It may add up to 13 or 97. So don't automatically assume that you write divide by 100, because you can lose 2 good marks on an easy question like this. So if they give you the percentages, then it adds up to 100. Also do double check. But if they give you relative abundance, then the equation is pretty much the same, but it's isotopic mass times relative abundance divided by total abundance. So this means it's not 100% 100, it might be 50 or 30 because it can vary, so just add it up. Also, let's quickly look at the definition of an isotope. What is an isotope? It contains same number of protons but different number of neutrons, e.g. chlorine 35 and we have chlorine 36. They both contain the same number, the atomic number, which is 17. However, this one contains 19 neutrons and this one contains 18 neutrons. So as you can see, neutrons have varied because that is an isotope. There are other isotopes of chlorine too, like 37, etc. These are just the 2 I've chosen. So let's quickly give you an example of working out the relative atomic mass. So let's look at gallium, however you pronounce it. So I've got 69 as the isotopic mass, and it has 60.1 as the percentage abundance. Sorry, that's a 6. Then I have 71, and it has 39.9. Work it out, it should add up to 100 because obviously I've given you the percentage. So we know definitely it will be divided by 100. Also, by looking at the number straight away, you know, if you add that join it into a calculator, it will add up to 100. So what you're going to do is 60.1 times 69, add 39.9 times 71, divided by, adding up the percentages, 60.1 add 37.9, which adds up to 100 we know, and that should give you 69.8 in the calculator. And that is all. That is your relative atomic mass. Now, I think that's pretty much it. I think that's all self-explanatory, and we will now go through some exam questions to really put in what we've learned into practice. So the first question is, explain how ions are accelerated, detected, and have their abundance determined in a time-of-flight mass spectrometer. So accelerated is a keyword, detected, and abundance determined. 3 things we looked at right now. So how would I answer this question? 1 mark for each point, simple. Accelerated, how are they accelerated? Remember we said by a negatively charged plate or electric field. That's all you would write. Nothing to do with ionization. Question hasn't mentioned ionization. You're going to go straight into it and you're going to say negatively charged plate or electric field. How is it detected? Well, we know a current is produced by gaining electrons, so by gaining electrons, you can write current is produced, which gains electrons, because when ions hit the detector plate, remember, they become discharged, therefore an electron is gained and a current is produced. However, all they want is gaining electron, short and simple like that. How is abundance determined? I'm just going to write abundance determined. How is abundance determined? Well, by the size of the current flowing or the amount of electrons gained, because we know that when it hits the detector, the electrons are gained, that's when a current starts to flow. So therefore, by the size of current flowing, by size of current flowing. Just remember that size of current is proportional to abundance of particles. So by the size of the current flowing is how it's determined. Obviously, because when an electron is gained by the detector, that's when the size of the current is measured, because therefore a current is produced. Calculate the mass in kilojoules of a single chromium ion, and they're giving the Avogadro's constant. So obviously that tells you you have to use Avogadro's constant, otherwise they wouldn't give it to you. We know they've told you specifically in kilojoules, and we know mass is given in grams. So to do grams to kilojoules, simple, just divide by 1,000. So first thing first I would do is, they've given you 52 as the mass, so I would straight away just divide that by 1,000 to give me 0.052, and we know this is now in kilojoules. And we also know that Avogadro's constant equation, hopefully you all know it, is number of particles. Sorry, ignore that. Number of particles equals mole of substance times Avogadro's constant. And you can put in a triangle if you want, like so. Avogadro's constant, remember what's so beautiful about it is that it can be used in terms of atoms, molecules and ions. So for this question it'd be perfect with ions. So once we've worked this out in kilojoules, we then divide that by 6.022 times 10 to the power of 23, and that gives us 8.64 times 10 to the power of minus 26, and that should be your answer. That is then we're gonna use that for the next part of the question, which is in a time of flight mass spectrometer, the kinetic energy was given as 1.269 joules. Calculate the velocity of the ion using the equation. So let's write down all the stuff we need first. Remember, we're gonna rearrange the equation before I wrote, which was 2ke over m. This is basically just rearranging that other equation that we looked at before, which was ke equals half mass volume squared. We're going to rearrange it to get this. That's what we need. So let's look at what everything, the units of it. So kinetic energy is in joules, mass is in kilojoules, volume, and yeah, that's it. So that's the volume of particles, the mass of the particles, and the energy. We know they've given us kinetic energy. Is it in the right units? Yes, it is. We know we've already got our mass, so we've got kinetic energy, we've got mass. We don't have velocity, so we're going to rearrange it. Simply plot it into the calculator, or write it down as 2 times 1.269 times 10 to the power of minus 13 over the mass that we got in the previous question, 8.64, because it's carrying on. Square root it all. Should give us 1.71 times 10 to the power of 6. And simple, that is your answer. So this is quite simple. It's literally just learning the equation. The equation is the only hard bit in it, to learn this equation by heart. Other than that, they've given you all the answers to it. It's just about rearranging it and memorizing the equation. Next question. Ions of two isotopes of iron are 53 and 56. Which statement is correct, not false? I still know so many students who make mistakes with that. So the ions of both the isotopes have the electronic configuration of that. That's just electronic configuration. That should be correct. That I will cover in another video. The ions of both isotopes contain 26 neutrons. Well, let's see. Fe53. 53, sorry. Let's just rub that out. So Fe53, Fe56, they both have the same atomic number, which is 26. This neutron contains 27 and this neutron contains 30. Obviously they're different, they're not the same, so we know this is also wrong. This is wrong. Fe53 has fewer protons than that. We know protons don't change in an isotope because the definition is same number of protons but different number of neutrons, so we know that's incorrect. However, we know D is therefore going to be correct, but let's read it and check. After acceleration to the kinetic energy will move more slowly than that. Yes, so we know that the velocity depends on the mass of the ion, and 56 is larger than 53, therefore they will have different speeds, and we know this is correct. So just circle that. There you go. 2.1. Right. A sample of sulfur containing of three isotopes has a relative atomic mass of 32.16. Table 1 gives us the relative abundances. It's given us percentage, so we know it should be over 100. Use the information to determine the relative abundance and hence the mass number of third isotope. So you need to read the full question. It says third isotope, so they haven't given you all the information. Some of it you need to work out yourself. First thing first, I would work out the missing isotope, which I'm going to put as X for now. Relative abundance. And how am I going to do that? I'm going to do 91 add 1.8, which gives me 92.8, to 100 minus 92.8, which gives me 7.2. That I know is the missing relative abundance. So I filled some of the information. Now I'm going to just put it out as I normally would. So 32 times 91, add 33 times 1.8, add X times 7.2 over 100 equals 32.16. So it looks a bit different because it equals something, but it's really easy because they've given you the relative atomic mass. It's just about rearranging it. So we're going to move 100 over to this side, and that's going to turn into times 100 because right now it's divide. Simple. So now we're going to write it down again. 32 times 91, add 33 times 1.8, hopefully I have space, add X times 7.2 equals 32.16 times 100. So now it's all in one line. Now I'm basically going to work it out. So 32 times 91, put it in a calculator, should give you 2,912. Add 59.4, which is basically 33 times 1.8. Add, obviously we can't put that in a calculator, so that's going to stay as X times 7.2 equals 32.16 times 100. Put that in a calculator, should give you 3,216. Therefore, we're going to move this all onto this side now. So that turns into minus. Therefore, it's going to be X times 7.2 equals 32.16 minus 2912 minus 59.4. And this then gives me X times 7.2 equals 241.6. Now the last thing we're going to do is move 7.2 over to the other side, so that turns into divide, and we know X equals 36, and that is our answer. So it is a bit long, but it's 4 marks, and there you get your 4 marks. Last 2 questions. Describe how ions are formed in a time of flight mass spectrometer. So ions are formed. You're going to have 2 answers in the mark scheme because there's 2 types of methods due to the ionization process. So we have the electrospray. So if you go with electrospray, your answer obviously would be high voltage applied, to polar solvent. Therefore, sample gains proton. This is just an example. Go with the other one, which is electron impact. This would be different as the sample is bombarded by electrons or electron gun. Therefore, sample loses electron. Simple. Describe how ions are formed, it said. So we know that during the acceleration stage, it can't be that, and it can't be the detection stage, and it can't be the flight tube stage. It has to be the ionization stage, because that's when the ions are formed. Therefore, that's why we only talk about that process, and it's only 2 marks. It's not telling you to list out all the processes part of the time of flight. It's telling you to choose which one it is by knowing in which stage the ions are formed. The last question. A time of flight mass spectrometer can be used to determine the relative molecular mass of molecular substances. Explain why it is necessary to ionize molecules when measuring their mass in a time of flight mass spectrometer. And this is also 2 marks. So, simple. Only ions, not molecules, can be So this is quite simple. Only ions, not molecules, can be accelerated by an electric field. So only ions can, so that's your first point. Only ions can be accelerated by electric field. Second one, only ions create a current when they hit the detector. Yeah, so we've spoken a lot about this. Only ions create current once they hit the detector. Obviously, once they hit the detector, that's then what causes the current. So 4 stages we know: ionization, which has electro impact and it has the electro spray. You then have the next stage, which is acceleration, so where they get accelerated by electro field, the negatively charged plate. Flight tube, which is basically based on the abundance and velocities, and detector, current produced, and they become discharged. Okay, so that is all. Please do carry on watching my videos, and this has come to the end of my video. I will carry on uploading more. Please do post any comments or anything you're unsure of. I will get back to you as soon as possible. Subscribe to my channel, follow me on Instagram called Talented Educators. If you need tutoring, I've got a website all written at the bottom. Please do keep me posted. Thanks.